Welcome back, Physics 30. We'll take a look at some hints for the FM2.8 daily work assignment. So maybe you'll go over a couple of questions. Some of the ones near the end are ones that are very similar to the ones that we did, so we don't need hints there, but some of these first ones we may need. So this first one, the coefficient of kinetic friction between a 22 kg crate and the floor is 0.3. So with this, we know mu k is 0.3, and the mass is 22 kgs. So of course, we'll be able to figure out the force of gravity quite easily. And of course, this scenario here is just simply a crate on the ground like this. Okay, and nothing else is going on. It says, what horizontal force would we need to apply in order to keep this moving at, now I have it circled, steady speed. That's the same thing as constant velocity. And of course, that's going to mean acceleration is 0, which means net force needs to be 0. And since we're told the coefficient of kinetic friction, we'll have to figure out that. So we'll be able to figure out this and this because these are equal and opposite. And then once we use the coefficient of friction equation to figure out FF, horizontally, we'll know what's going on. So you're going to have to figure out vertically what's going on. So vertically we have FG and FN. And since this isn't accelerating upwards or downwards, we can assume that's going to be 0. And then, so we'll figure out that. And then horizontally, of course, we have, F net is equal to FA plus FF. And yes, since we're moving at steady speed, that's going to have to be 0 as well. So that's a hint for that very first question there. You may want to draw these diagrams, maybe not take up that much room because there isn't a lot of room to go there. With question 2, here's a hint. So it says here a force of 35 newtons is required to start an object moving. So we can think of that as your 35 newtons, Fa, is what you need to apply to basically overcome the force of friction. So guess what? If that's the maximum that I need, FF is going to be negative 35 newtons. Of course, we have FG and FN, which you can easily figure out. We have the mass of the box. You can figure out FG as usual. And you should be able to figure out what that, and then of course vertically, same thing we usually do. F net is equal to Fg plus Fn. Nothing's going to be accelerating up or down, so we'll figure out that. And so horizontally, of course, we don't have to figure this out, but horizontally, of course, we're just at the point of starting it, so the net force is 0. So that's how we rationalize that Fa and Ff must be equal and opposite. And of course, to figure out mu, it's FF over Fn. Because we'll have friction, we'll have Fn, and again, in this equation, the ratio, we're not concerned about the negative that we see over here. Okay, so we just simply use the magnitude only. Okay, with part B of that question number 2, we have it so it surpassed the coefficient of static friction, and now it's moving and accelerating, so it's overcoming moving friction now, kinetic friction. So here we have our FA. Our FA is, we're still applying 35 newtons. Okay, and we're told that it's accelerating now. So if we know what an acceleration is, we can figure out F net. Okay, once you have F net, then you can analyze this horizontally. F net is equal to Fa plus Ff. So you'll have that F net value put into there. We have Fa. So you'll be able to figure out FF. Then, of course, we'll be able to figure out the coefficient of kinetic friction by using the kinetic friction force from here divided by Fn. Okay, so those are some hints for this assignment. Question 3 is one that's very similar to that we did together in the previous video. And number 4 is an inclined plane question, very similar as well. So you should be able to just look back in your notes and figure out how to do those ones. All right, see you again.